Ever wondered how scientists figure out what materials are made of right down to the atomic level? Welcome to the fascinating world of materials characterization, where we unlock the secrets of everything from metals to polymers using some pretty amazing tools and techniques. So, what is characterization in materials science? It's the process of probing and measuring the structure and properties of materials. Imagine it as a detective story where each technique brings us closer to understanding why materials behave the way they do, whether it's a smartphone screen, an airplane wing, or a simple kitchen pan. Let's start with microscopy. This is all about looking closer, much closer. Optical microscopy is the classic version using light to magnify samples, great for seeing things like grain structures in metals. But when we want even more detail, we turn to electron microscopes like SEM and TEM, which can reveal features down to the nanometer scale. There's also atomic force microscopy, which uses a tiny probe to feel the surface of a material, mapping out even single atoms. Now, onto spectroscopy. Instead of just looking at materials, spectroscopy is more like listening to them. By shining light or other radiation on a sample, we can detect what elements or molecules are present. UV visible and infrared spectroscopy are common for organic compounds, while X-ray spectroscopy, like X-ray diffraction, shows us the atomic structure of crystals. Techniques like EDS and XPS give us precise details about a material's composition, often used in everything from geology to electronics. Mass spectrometry is another game changer. Here we blast samples with energy to break them into ions, then measure their mass. This tells us exactly what elements and even isotopes are present. Techniques such as MALDI-TOF and SIMS are especially useful for polymers, biomolecules, and even tiny contaminants. Let's not forget nuclear spectroscopy. Nuclear magnetic resonance, or NMR, is widely used in chemistry and biology to uncover molecular structures. Mossbauer spectroscopy and perturbed angular correlation are more niche but super powerful for studying tiny changes around specific atoms. Beyond the microscopic, we also need to test the big picture, literally. Macroscopic testing measures bulk properties like strength or thermal behavior. Think tensile tests for metals or thermal analysis for polymers. These tests tell us how materials will perform when the rubber meets the road, whether that's inside a jet engine or a laptop. And here's the cool part. New techniques are emerging all the time. Atomic force microscopy, for example, has only been around for a few decades and already revolutionized fields like nanotechnology. So in materials, science characterization is the backbone of discovery. Without it, we'd be stuck guessing how materials work. Thanks for joining me on this quick tour. Next time you use any modern gadget, remember it's all possible thanks to the science of seeing what's really there.